Stars. Stars are the most numerous and important astronomical objects. These huge, brilliant plasma spheres are mostly hydrogen and helium. Nuclear fusion events in star cores combine hydrogen atoms into helium, unleashing massive amounts of light and heat. They vary in size, temperature, and lifespan. Smaller stars like red dwarfs can burn slowly for trillions of years, while massive stars burn hotter and usually explode in supernovae. Our solar system is anchored by the medium-sized G-type main sequence star, Sun. Fusion and stellar death create most elements in the cosmos, making stars crucial to the cosmic cycle. Planets. Planets circle stars and have cleansed their orbits of junk. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune are terrestrial planets and gas-giant ice giants in our solar system. While Jupiter and Saturn are mainly hydrogen and helium, terrestrial planets like Earth and Mars are rocky. Complex atmospheres, magnetic fields, and interior geology exist on some planets. Astronomers have found thousands of exoplanets, some of which may have liquid water, bolstering hopes for extraterrestrial life. Moons. Moons, or natural satellites, are celestial bodies that orbit planets or dwarf planets. Earth's moon is just one of more than 200 known moons in our solar system. Some moons are geologically inactive, while others are surprisingly dynamic. For example, Jupiter's moon Io is the most volcanically active body in the solar system, while Europa and Saturn's Enceladus are believed to have subsurface oceans beneath their icy exteriors, potentially harboring microbial life. Titan, Saturn's largest moon, has a thick atmosphere and lakes of liquid methane, making it one of the most Earth-like bodies in terms of weather and surface features. 4. Dwarf planets. Dwarf planets are planetary mass objects that orbit the Sun and are nearly spherical, but haven't cleared their orbital neighborhood of other objects. Pluto, once considered the 9th planet, is now the most famous dwarf planet, joined by Eris, Haumea, Makemake, and Ceres. These objects reside mostly in the Kuiper Belt, a region beyond Neptune filled with icy bodies. Ceres is the only dwarf planet located in the asteroid belt and shows evidence of water, ice, and potential cryovolcanism. Though small in size, dwarf planets help scientists understand the history and evolution of the solar system's outer regions. 5. Asteroids. Asteroids are rocky, airless remnants from the early solar system's formation, mostly found in the asteroid belt between Mars and Jupiter. They range in size from tiny boulders to dwarf planet-sized objects like Ceres. Composed of rock, metal, or a combination of both, asteroids can offer valuable insights into the materials that form the planets. Some asteroids have orbits that bring them close to Earth, known as near-Earth objects, the NEOs, and are monitored for potential collision threats. Missions like NASA's OSIRIS-REx have successfully collected samples from asteroids like Bennu to study their composition and structure. 6. Comets. Comets are icy celestial bodies that originate from the distant regions of the solar system, such as the Kuiper Belt and Oort cloud. When a comet approaches the Sun, the heat causes its ices to vaporize, releasing gas and dust that form a glowing coma and long tail. This tail can stretch millions of kilometers and always points away from the Sun due to solar radiation and wind. Comets are considered some of the oldest, most primitive objects in the solar system, preserving the building blocks of planets. Famous comets like Halley's Comet and Comet Neowise provide spectacular views and valuable scientific data. 7. Meteoroids, meteors, and meteorites. Meteoroids are small chunks of rock or metal that travel through space. When one enters Earth's atmosphere and burns up due to friction, it becomes a meteor, commonly referred to as a shooting star. If any part of it survives the journey and reaches the ground, it's called a meteorite. These space rocks can vary in size from a grain of sand to several meters across and often originate from comets or asteroids. Some meteorites are billions of years old and contain clues about the early solar system and the formation of Earth. 8. Black holes. Black holes are regions of space where gravity is so strong that not even light can escape. They form when massive stars collapse under their gravity after a supernova explosion. There are 3 main types: stellar mass black holes, intermediate black holes, and supermassive black holes, the latter residing at the centers of galaxies, including our Milky Way. Black holes are detected indirectly by observing how they affect nearby matter, such as accretion disks and gravitational lensing. In 2019, astronomers captured the first direct image of a black hole in galaxy M87 using the Event Horizon Telescope, marking a major milestone in astrophysics. 9. Neutron stars and pulsars. Neutron stars are the ultra-dense remnants of massive stars that exploded in supernovae. Despite being only about 20 kilometers in diameter, they can contain more mass than the Sun. Their densities are so extreme that atoms collapse into neutrons, forming an incredibly compact object. Some neutron stars emit beams of electromagnetic radiation from their magnetic poles. And if these beams sweep past Earth, we detect them as pulsars, highly regular pulsing radio signals. These cosmic lighthouses are critical tools for understanding gravity, space-time, and the fundamental nature of matter. 10. White dwarfs. White dwarfs are the remnants of low to medium mass stars like our Sun after they have exhausted their nuclear fuel. After shedding their outer layers as a planetary nebula, the remaining core cools and shrinks into a white dwarf, a dense, Earth-sized object. These stars no longer undergo fusion and slowly radiate their heat over billions of years. Eventually, they may cool into hypothetical black dwarfs, though none currently exist due to the age of the universe. White dwarfs often exist in binary systems and can trigger Type I supernovae if they accumulate enough mass from a companion star. 11th. Galaxies. Galaxies are enormous collections of stars, gas, dust, dark matter, and other astronomical objects bound together by gravity. They come in various shapes, spiral, elliptical, and irregular, and range in size from a few million to trillions of stars. The Milky Way, our home galaxy, is a barred spiral galaxy containing over 100 billion stars. Galaxies often contain supermassive black holes at their centers and can merge with others in dramatic collisions. The Andromeda Galaxy, our nearest large galactic neighbor, is on a slow-motion collision course with the Milky Way, set to occur in about 4.5 billion years. Nebulae. Nebulae are vast clouds of gas and dust scattered throughout galaxies. They are often stellar nurseries where new stars are born. Emission nebulae glow with light from nearby stars, ionizing the gas, while reflection nebulae shine by reflecting starlight. Dark nebulae, such as the Horsehead Nebula, obscure light from objects behind them due to their density. Planetary nebulae form when dying stars shed their outer layers, creating stunningly colorful shells of gas. The Orion Nebula is a well-known example visible to the naked eye and remains a major target for telescopes and astronomers alike. 13. Quasars. Quasars are the extremely bright and energetic centers of distant galaxies powered by supermassive black holes actively consuming matter. As material spirals into the black hole's accretion disk, it heats up and emits radiation across the electromagnetic spectrum, outshining entire galaxies. Quasars were more common in the early universe and serve as cosmic lighthouses, helping astronomers study galaxy formation and the expansion of the universe. Some quasars are so distant that their light has taken billions of years to reach Earth, offering a glimpse into the young cosmos. 14. Exoplanets. Exoplanets are planets located outside our solar system that orbit stars in other planetary systems. Thanks to missions like Kepler and TESS, thousands of exoplanets have been discovered using techniques like the transit method and radial velocity. Exoplanets come in all sizes and types, from hot Jupiters orbiting very close to their stars to Earth-sized rocky planets in habitable zones. Some of the most promising candidates for life exist in systems like TRAPPIST-1, which hosts several Earth-sized worlds in its habitable zone. With the James Webb Space Telescope, scientists are now studying their atmospheres for signs of habitability. Like, subscribe, and click the bell for more space content if this cosmic adventure blew your mind. Comment below with your favorite object and if you want us to explore it in another video. Keep looking up until next time. The universe awaits exploration.